Good evening, everyone. So, in this continuous classes, today, tomorrow, and maybe day after tomorrow also, we are going to finish tree data structure. Okay, tree data structure. Under that, what topics are there? Sir, very simple. Here we are going to see introduction to tree data structure, introduction to tree data structure. Next and after that, terminologies. Okay, terminologies. There are some terms are there which are related to the graph. Which are related to the tree. So that tree terminologies are okay. Terminologies of a tree, because there are some words will be there like in order, pre-order, post-order, height of the tree, degree of the tree, like that. Multiple terms will be there. So that we are going to discuss. Next and after that, there is one concept is there called a binary tree. Binary tree means what? Theoretical part. And binary tree implementation. Implementation we are going to see. And next and after that, binary search tree is there. Binary search tree. So in short form, we are calling it as a BST and a BST implementation. So these things we are going to cover in today's session. So tomorrow I am going to explain AVL trees. So with this, the tree data structure is going to be finished. So let us see in detail. Sir, already for first batch and second batch, already I covered, I think up to binary tree like this I covered, but just consider this as some kind of revision. Please listen carefully. Can I start? Please confirm.
Yes, sir.
Right.
Yeah.
Sir, yeah. Sir, 11 o'clock batch students are there, right? Can you please confirm? Who is 11 o'clock student batch? Please confirm. Abhishek.
Yes, sir. Start.
Yes. Next. Only Abhishek.
Yeah, I'm also.
Sir, I
Yeah,
am also. Ranjit.
Bharat. Okay. Bharat Ranjit. Good. 1 second. Let me put a message in the group. Right. Sir, now what is this tree? What is this tree? Sir, maybe I think you have seen how you are going to represent the tree. Something like in general, sir, basement will be there. Okay, on this you are going to see a tree like this, right? This is the general tree where the roots will be available here. Okay, the roots will be there. But coming to the programming, completely reverse. Okay, root will be there in the top. For this, children will be there, branches, like this it will be. Sir, again, some branches are there. For this, if you want, again, you can extend some branches. Like this you will have. Sir, do you know this type of representation is called as a tree? Or if you want more meaningful, sir, do you know in the colleges, management will be there. Okay, management will be there. Under this, principal is nothing but the highest authorized person, and academic advisor will be there. Okay, and under that principles, so civil HOD, okay, so triple E department HOD, so ECE HOD, like this head of the departments will be there. In this academic advisor or so some other person will be there. So those are having some accountant, admin related, so extra activities will be maintained here. Okay, sir, do you know this representation is also called as a tree? Sir, means what? I can say hierarchical representation. When we can go for a tree, so if we want to represent, if we want to represent the data, if you want to represent the data in the form of, sir, hierarchical relationship. So then you can go for this tree data structure. Okay, sir, it is non-linear data structure. It is non-linear data structure. means what? Non-linear means what? Continuity won't be there. Sir, can I say in the array after third index, which element will be there? Fourth index. In the string after fifth character, sixth character will be there. Okay, in the stack, suppose in the bottom, if I have element 10, what is the next element? Yes, you can. In the queue, I have one element is there. What is the next element? Yes, you can. But in the tree, if one element is there, sir, what is the next element to this? You can't give because it is not represented in a sequential manner. Continuity won't be there. These kind of data structures are called as what, sir? Non-linear data structure. The data is not in a linear fashion. Sir, I can say it is nothing but a parent and a child relationship. We can consider this one as a parent and child relationship. Okay, it is called as parent and child relationship. Like this we have. Sir, it is the best suitable for search operations. Search operations. Sir, something you have seen in our beginning sessions, I told binary search, right? Binary search algorithm. Already we have seen how the name binary search algorithm came. This is the concept, sir. Is the binary search algorithm is the efficient algorithm or not? Yes. Sir, why? First, you will compare the data with root node. The elements which are less than this root node will be available in this. The elements which are greater than the root node will be available here. Sir, what about this link? Forget about this. We have some properties are there. There I will explain. Like that. Sir, now again this data will be compared here. Then we will take whether it is in there in its left or in its right. Like that, number of comparisons we are going to deduct. That's why binary search algorithm is a best example for this tree data structure. So binary search algorithm is implemented based on this tree data structure only. Sir, what is the time complexity for linear search? Definitely it is going to take big O of n. What is the time complexity for binary search? Every time you are dividing the list, right? So it is going to take log n time complexity. Like this we have. Sir, now everything is okay, but what is the definition of tree? Sir, I can say tree is a finite. Okay, tree is a finite set of one or more nodes. So it is a finite set of one or more nodes such that what is the first rule here? So there is a specially designed node will be there. So called as a root node. There is one specially designed node will be there. That name is nothing but root node. So second one is nothing but, do you know, remaining nodes? Remaining nodes are partitioned. Remaining nodes are partitioned into n greater than or equal to 0. N greater than or equal to 0 disjoint sets. Sir, how the remaining nodes are partitioned? N greater than or equal to 0 disjoint sets. Some divisions will be there. Like that it is going to partition. Sir, what are the examples of our trees? If you want, just have a look once. Sir, is it a tree or not? Yes. 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 Sir, connections I have to establish. Here only one child is there. Here two children are there. So here we have three children are there. Do you know, if you are representing like this, sir, here I am going to take it as, sir, T0. Sir, this one is nothing but a T0. So T1. So this is nothing but a T0. So T1, T2. This is nothing but a T0. So T1, T2, T3. Okay. Sir, a tree is nothing but a finite set of one or more nodes. Here one node, here two, here three, here four, like that. Sir, there is one specially designed node is there. What is the name of that specially designed node? Root node. Can I say, is it a root node? Yes. Sir, can I say this one is a root node? Yes. This one is a root node. This one is a root node, like this. What about remaining nodes? Remaining nodes are partitioned into n greater than 0. 0 subnodes are there, 1 subnode, sir, 2 children, 3 children, like that it will be having. This is nothing but what we can able to consider as a tree, sir. Can you please confirm, is the introduction to this tree data structure, is it clear for you people?
Yes, sir.
Yeah, clear, sir.
Please respond everyone, clear?
Yes, sir.
Now, sir, in this, we have to talk about some terminologies related to the tree. Okay, so tree data structure terminologies. So what are the different types of terminologies that we have? First one is nothing but root. Sir, what is mean by root? I can say it is nothing but a unique node. It is nothing but a unique node having only outgoing edges. Sir, root means what? It is a unique node which is having only outgoing edges. Let us take one example. So to demonstrate this tree, sir. Okay, I want to take one example for demonstrating this tree. Let us take one simple example I'm going to take here. Okay, sir, in that every word meaning we are going to see. 1 second. Yeah, so let me take one simple tree I'm going to draw. For example, consider I'm going to take 7. 7 is nothing but a root node. So 7, 5 is there, it's a children. Or let me represent in alphabet so that we can able to understand. Let us take this one is A, and this one I am going to consider it as a B. B is one child, so C is one child, so D is another child. So for B, E is nothing but another child, F is nothing but another child, G is nothing but another child, H is nothing but another child, I is nothing but another child. Like this we have. Sir, can you please tell me, in this tree structure, which node is called as root node, sir? Please confirm.
Yes, sir.
Yes, here
A is
A is called as root node. Now, the next one is nothing but node. Very, very important. Please listen. In the linked list already we covered, right? Same thing. Node means, sir, this one is called as a node. This one is called as a node. How you are going to represent? In single linked list, sir, we have represented this node in the form of a single pointer with so only one field. But this tree data structure, you have to maintain a single data field, 2 pointers field will be there. Okay, sir, node is nothing but what? It is a fundamental. It is a fundamental element of a tree. Okay, so each node each node contains the following 3 fields will be there. Of course, this is not a tree diagram, a binary tree it is going to follow, but in the tree, just we are going to take for definition purpose. That's why you can ignore this node structure for the tree. Now, what is the first one? It is going to have data field. Data field. Data field means what, sir? In this, we are going to store our actual information. What is the next field? We have left pointer. In the data structures, I mean, in the linked list, we are going to use the terminology called, okay, previous node. That is, here it is represented by using left pointer. Here it is represented by using left pointer, sir, pointing to pointing to the left child, pointing to the left child. And what is the third one, sir? It is nothing but right pointer. Okay, right pointer, which is pointing to the right child, which is pointing to the right child. Here we are going to have two pointers will be there, left pointer and right pointer. Left pointer is always pointing to the left child, right pointer is always pointing to the right child. That anyway we will see in detail. Sir, what about the next term? Edge. Edges will be there. Sir, what is mean by edges? Very simple. It is also a fundamental. It is also a fundamental part. A fundamental part of a tree. Sir, which is used to connect. Which is used to connect two nodes. If I want to connect two nodes, then we have to go for these edges. Sir, you can see in the tree, first root node is having a connection with the three subnodes, right? Then AB is one edge, AC is one edge, AD is one edge. So BE is one edge, BF is one edge, CG is one edge. So DH is one edge, EI is one edge. Like that, we have the connections is there like this. Okay. So these are nothing but called as edges. And there is one more concept is there with name path. Path. What is mean by path? An ordered, okay, an ordered list of nodes so that are connected by edges, that are connected by edges are called as path. So an ordered list of nodes that are connected by edges are called as paths. For example, if you take A to I, A to I, is there any path? Yes. First we have to go to A to B, then we have to go from B to E, then we have to go from E to I. This is called as a path. Path means what? From root node to, so which node you are asking? Till that, what are the edges are there? That edges connection you have to make. Then it is called as what? Path. Then it is called as what? Path, sir. Like this we have. Please tell me what is the definition of this tree? How to represent this node? Edges means what? Path means what? Is it clear up to this whatever I covered? Please confirm.
Yes, sir.
Yes, sir.
Clear, sir.
Right. Next, sir, one more terminology. Leaf nodes. Leaf nodes. There is one terminology is there with name leaf nodes. Sir, first one is root. Edge means we know. Node means we know. Path is also we know. What is leaf node? Leaf node means very simple, sir. The nodes, okay, the nodes which are not having, the nodes which are not having any children. Okay. The nodes which are not having any children are called as leaf nodes. The nodes which are not having any children are called as leaf nodes. That is without outgoing edges, outgoing edges. Sir, in this tree, can you tell me which are leaf nodes?
IFGH.
Yes, I is
IFG.
not having any child, F is not having any child, G is not having any child, H is not having any child. But for remaining all the nodes, children are there from the root. Okay. Next and after that, I want to talk about height of the tree. Height of the tree. Sir, what is mean by height of the tree? Very simple. So height of the tree is sum of edges on the longest path. Okay, longest path between root and leaf node. Root and leaf node. If you take root and leaf node, what is the highest path, longest path that you have to take? Sir, what are the leaf nodes that we have? A to I, definitely one path will be there. Then A to F, definitely one path will be there. Then A to G, definitely one path will be there. A to H. These are nothing but leaf nodes, right? You need to calculate, sir, all the paths, longest path you have to find out. Sir, A to I. So first we have to go to A to B. So then B to E, then E to I. Like this you have to take. How to go to A to F? Sir, A to B, then we have to take a B to F, right? Then how to move from A to G? Sir, A to C, then you have to go to C to G, right? Sir, how to move from A to H? A to D, and then D to H. Sir, can you please tell me which is longest path here?
A to I.
A to I. So how many edges are there from A to I? Can you please tell me?
3.
3. So height of the tree is nothing but what? 3. So height of tree is nothing but what, sir? 3. 3. Because the longest path you have to calculate and you need to decide. Okay. Next. Sir, we have to talk about level of the tree. Level of the tree. Sir, what is mean by level of the tree? Very simple. The level of the level of a node or the level of a tree, okay, is so number of edges on the path from root to that node. So level of tree means what? It is nothing but the level of node or tree is nothing but the number of edges on the path from root to that node. Sir, now let us take one example. Sir, A. What is the level of A? How many number of edges are there? There is no edges. So it comes under 0 level. Sir, for the node B and C and D, these are at which level? First level. Because one edge is there, right? That you have to count. Then, sir, E, F, G, H. So what is the level of this one? 2. Because those nodes are having 2 connections. Then, sir, I is there at which level? Third level. Like this we have. So level of a node or level of tree is nothing but what? Sir, in which levels it is available? Please make sure always this will be there at 0th level. This will be there at first level, second level, third level, like this. When you are constructing the tree, you will get clarity on this. Can you please confirm how to calculate this level and how to calculate this height? Is the concepts are clear up to this whatever I covered?
Yes, sir.
Clear, right? Right. So the next terminology is nothing but parent. Parent. Sir, what is mean by parent? A node. So a node is a parent of all the children. Of all the children. So that are linked by outgoing edges. That are linked by outgoing edges. Sir, what are the parents in this diagram? A is a parent because outgoing edges are there. Of course, it is a root, but in addition to that, first of all, it is a parent. Sir, B is a parent because it is having 2 children, E and F. C is the parent because it is having 1 children called G. D is also parent because it is having 1 child is H. E is also parent. Sir, what about F? F is not a parent because it is not having any children. So G is also not a parent because it is not having any children. H is also not parent. I is also not parent. Like that we have. This is nothing but what is meant by parents. Sir, what about the children? What about the children? Sir, children is nothing but very simple. The nodes, so that are having the nodes that are having incoming edges are called as what? Children. So the nodes which are having incoming edges are called as children. Sir, can I say B is a child? Yes. C is a child? Yes. D is a child? Yes. E is the child? Yes. F is the child? Yes. G is the child? Yes. H is the child? Yes. I is the child. Sir, except root node, everything is nothing but child. Sir, in this some are parent? Yes. If you take a B, B will act as a both a parent and child. For whom B is parent? For E and F. For whom it is child? For A it is child. Like that, some nodes will be there which are acting as a parent and child. Okay. So which nodes won't act as a parent and child? Root node and leaf nodes, because root node don't have any incoming edges. Leaf nodes, it doesn't have any outgoing edges. Like that we have. The concept is clear, friends. Please confirm.
Clear, sir.
Sir.
Yes, Bharat.
Yeah, yes, sir.
Right. Next, sir, we have siblings are there. Siblings means what? Sir, the nodes which are related to the same parent, the nodes which are connected with the same parent are called as siblings. The nodes, okay, in the tree, the nodes in the tree, okay, the nodes in the tree, so that are connected or that are children of a same parent are called as siblings. Can I use this word? Yes. In this example, can I say B, C, D, these three are siblings? Yes, because common parent is there. Can I say E and F are siblings? Yes. Is there any siblings? No. Okay, so if any two nodes or more than two nodes are connected to the same parent, then those are called as siblings. Sir, all are normal family tree diagram. If you imagine, you can able to understand each and everything. Okay, so if you take some 2 or 3 generations, you can get all these terms very clearly, sir. There is no difficulty in this. Then, sir, next terminology, I'm going to talk about degree. So degree of a tree. So degree of a tree. Sir, how you can calculate the degree of the tree? Sir, degree is nothing but, okay, the total the total number of subtrees, the total number of subtrees attached to that node is called as degree, degree of that node. Okay, the degree of that node or tree, something like that we can call. So first let me define degree of node. Sir, what is mean by degree of node? The total number of subtrees attached to that node is called as degree of the node. Let me take some examples. Sir, if you take degree of A, what is the degree of A? How many subtrees are attached? 3. What is the degree of B? Can I say, is it 2? What is the degree of C? It is nothing but 1. Sir, what is the degree of D? It is nothing but 1. What is the degree of E? It is nothing but 1. What is the degree of F? It is nothing but 0. So like that we can tell. That means how many outgoing edges are there you can count. Or sorry, not outgoing. Sir, how many subtrees are there? So that means it should maintain again a tree. So like if you have, then that is called as degree, sir. Yes, something like outgoing edges on how many edges are moving from that. Sir, what about degree of a tree? Degree of a tree. Sir, what is mean by degree of tree? Sir, very simple. Sir, maximum edges. Okay, maximum degree of each node. Maximum degree in the tree is called as degree of the tree. Sir, in this tree, you can see what is the maximum degree? 3, right? Because you can see 3, 2, 1, 1, 1, 0. Among these, maximum is nothing but what? 3. Like this we have. Sir, next one, we have ancestor is there. Ancestor is there. What is mean by ancestor? Very simple, sir. A node which is reachable. A node which is reachable. So a node which is reachable through, okay, through repeated. So through repeated moving from child to parent. If you move from child to parent, whatever nodes that you are going to get, those are called as ancestors. For example, take a node called I. Sir, for node I, which are ancestors? Can I say E? Yes. Sir, can I say B? Yes. Can I say A? Yes. All these three are nothing but what? Ancestors for the node I, sir. Sir, please confirm how to calculate degree of the tree, how to calculate the degree of the node, and what is mean by this ancestor. Is this small terminologies are clear for you people?
Yes, sir.
Yes, sir.
Clear? Right. Now, so let's go for the next one, sir. So another 2 definitions are there. With that, theory part is going to be finished. Sir, predecessor. Predecessor. There is one terminology is there called predecessor. Sir, while displaying the elements, while displaying the nodes, okay, so in the tree, while displaying the nodes in the tree, okay, if a node appears, or if a node comes before another node, then that node is called as predecessor means what? Something like a previous node. In this example, sir, E is predecessor of I. That means while moving for I, what is the previous node that you visited? E. But don't feel that it will be always E. If the structure is going to change, it will change. That I will explain later. Okay. So next one is what? Successor. Sir, same definition will be there for successor. What is mean by successor? While displaying the nodes in the tree, if any nodes comes after another node, okay, after another node, then it is called as what, sir? Successor. Like this we have the word. In this example, if you take, sir, do you know how to represent? Yes, I can say F is, okay, F is, sir, successor of I. After I only F is going to come. Okay, after I only F is going to come. Okay, F is nothing but a successor of I. So which one is a predecessor of I? E is the predecessor of I. That means first E, then I, then EF. Like that we are going to get. So that is depending on the traversal technique which you are going to use. That I will explain in the application, sir. Don't worry at all. These are nothing but what are the different types of terminologies what we have to understand the concept of tree. Okay, I am repeating one more time, sir. Please listen. So first, what is mean by root? The topmost element which is not having any incoming edges and having only outgoing edges. Node means what? How we can represent? In the form of double linked list we will represent. Edge means what? Path means what? Leaf node means what? Height of the tree, level of the tree, parent node, child node, siblings, degree of the node, degree of the tree, ancestor, predecessor, successor. I think these terminologies are very clear for you people. Sir, we are going to use these terms one by one while implementing the program, sir. Can you please confirm, is the concept is clear up to this whatever I covered?
Yes, sir.
Please confirm, friends.
Yes,
Clear,
sir.
sir.
Right. Now the actual concept is going to start now. More concentration must be required. Okay. Please don't think anything in your brain. Okay. Because this program itself is going to create a confusion for us. So we are going to talk about the main tree data structure now. Actual concepts will start from here only. Sir, what is the first one here is I'm going to talk about binary tree. Okay, what is mean by binary tree? And we will get programs from here. Binary tree. Already we have seen the terminologies which we are using in the tree. So with the help of that, I want to define binary tree. Binary tree is a type of tree. Binary tree is a type of tree in which each node has at most two children. That means maximum how many children should be there? Either 0 or 1 or 2. That's all, sir. At most 2 means what? Either 0 or 1 or 2. So which are okay, which are referred as left child, which are referred as a left child and right child. Okay, which are considered as a left child and right child. Sir, now in binary tree, So each node will have data field, okay, and two pointer fields pointing pointing to the left and right subtrees, pointing to the left and right subtrees. Like this we have. Sir, means what? Just for your understanding purpose, I am taking paint. Please have a look once. Now have a look once. Sir, consider I am taking a small node like this. So this is nothing but a T0. Can you tell me, is it a binary tree? Please confirm. Is it a binary tree?
Yes, sir.
Yes, because there is no left child, right? Can I represent this as a none? And there is no right child. Can I represent this as a none? Yes, it is a binary tree, sir. Now I have one node is there, only left node is there, okay, so which is nothing but a T1, and there is no right node. Can I say is it a binary tree? Yes, because left pointer is there, right pointer is not there. Sir, now T0, now left pointer I am going to remove and I am going to take a right pointer. Yes, it is also a binary tree. Suppose consider I have T0, left pointer is there, left node is there, at the same time right node is also there. Sir, can I say is it a binary tree? Yes, all these are binary tree. Suppose if I am taking T0, so T1 is there and T2 is there and T3 is there. Is it a binary tree?
No.
Please confirm. No,
No,
it
sir.
is not a binary tree. So first of all, it is a tree, but it is not a binary tree. Why? Because a tree means what? Any number of nodes it can contain, child nodes. But a binary tree means what? Child nodes can be either 0 or 1 or 2. That's all. More than 2 is not allowed. Please confirm, everyone, especially 11 o'clock students. Please confirm, is this binary tree definition? Is it clear for you people?
Yes, sir.
Clear, sir.
Right. Now we will see how to implement this binary tree, sir. Binary tree implementation. Here you are going to get the program. Please concentrate well. So there are two ways are there. There are two ways are there to represent. There are two ways are there to represent binary trees. There are two ways are there to represent binary trees. What is the first way, sir? It is nothing but I can say sequential representation. What is the first way? Sequential representation. What is the second way? Linked list representation. Linked list representation. Sir, in the sequential representation, we have some formulas are there. Okay. In the sequential representation, we have some formulas are there. By using that formulas, we are going to consider. Have a look once. If you take sequential representation, in this sequential, okay, in this sequential representation, if a node is present at nth location, if a node is present at nth location, then sir, where its parent will be there? In nth location. So where its left child will be there? Its left child is going to present at 2n plus 1. Where its right child will be present? It will be present in 2n plus 2. Sir, let us take one simple example. Okay, let us take one simple example. Sir, I am representing the tree in the sequential format. Sir, 0, 1, so 2, 3, 4, 5, 6, 7, like this I am taking. Locations 0, 1, so 2, 3, 4, 5, 6 I am taking like this. Please listen carefully. First I am taking n is equal to 0. N is equal to 0. Sir, n is equal to 0 means what? Parent is 0. Okay, parent is 0. So 0th node is nothing but a parent. In 0th location, which element is there? 1. 1 is the parent. Okay, completed. What is its left child? How to find out left child? Left child of 0 is nothing but left child of 0 is nothing but, sir, can I take 2n plus 1? N is what? 0. N into 0. 2 into 0 will become 0 plus 1. In first location, which element is there? 2. That will become its left child. Sir, what about right child? So your right child of this parent node will become, so 2n plus 2. In the n place, I am taking 0. 2 into 0 plus 2. Sir, which is nothing but 2. In second location, which element is there? 3. Sir, can I say this is nothing but like this? Yes. So this is nothing but the first level. Next, I'm going to consider parent as a 2. Sir, parent as a 2. 2 is parent means what? So in which location it is available? 1. So n is equal to 1. So in first location 2 is there. For this 2, we have to identify left child. Sir, what is the left child of this one? 2 into 1 plus 1. That is nothing but 2 plus 1, which is nothing but 3. In third location, which data is available? 4. Sir, can I say it is nothing but left child is nothing but 4? Yes. What about right child? Right child of first location. Sir, 2 into 1 plus 2, which is nothing but 4. In fourth location, which data is there? 5. That will become your right child. Sir, next n value is nothing but what? 2. So left child of 2 I am taking. Sir, in second location, which node is there? 3. For 3, we are finding the left child. So can I say 2 into 3 plus 1? Which is nothing but a 6, 2 into 3 or 2. Sorry, 2 into 2 plus 1. That is 4 plus 1, 5. In fifth location, which element is there? In fifth element, which location is there? 6. Sorry, in fifth location, the element 6 is there. It will become left child. So what about right child of 2? So 2 into 2 plus 2. So what is its value? 4 plus 2, 6. In sixth location, which element is there? 7. That will become another parent. Sir, all the data got completed, right? That's why. This is nothing but what we have. Sir, can you please confirm? Is the sequential representation of this tree? Is it clear?
Yes, sir.
Yes, sir.
Yes, Abhishek, Bharat.
Yes, sir. Clear.
Yes, sir. Clear, sir.
Right. Next one. Sir, how to represent these in linked list format? How to represent this in linked list format? Very simple. I am not writing any code here. So I will write only single line. We can use double linked list. Okay, double linked list to represent tree data structure in linked list formats. Don't worry, in all the programs, whatever applications that we are going to develop on trees, it will be implemented in the linked list only. That's why I'm not going to cover. Okay, next. Sir, if I create a linked list, I have to see what is the content present in the linked list, right? If you create a tree, sir, it is a completely imagination process, right? Whatever I told diagram. So everything is imagination. If it is array, sir, we can represent like this, like 10, 20 will be there, 30 will be there. So you can see in the output also like this we will get. Array, if I am taking 20, so 10 and then 30 and then 40. Sir, how you can represent this diagram in the output? We can't represent, right? So even suppose consider I am taking like this 20, so 10, 30, 40. Sir, can I take this 40 like this also? Then what is the difference? That's why for this representation, I mean, if you represent this tree data structure in the program, sir, we have to concentrate on one special function, which is nothing but very, very important, binary tree traversals. Binary tree traversals. What is mean by binary tree traversals? Very simple, sir. Traversing means visiting. Okay. So traversing means visiting each node, once in a tree. Every node you have to visit one time. Okay. Sir, it is also called as displaying. Okay. So displaying each node present in the tree, like this we have. So the following are the three ways. The following are the three ways to display the elements in the tree. Sir, whether it may be tree, or whether it may be binary tree, or binary search tree, or AVL tree, or red black tree. Okay, red black tree, or you can take B plus tree. Okay, or you can take split tree. Any tree you can take, sir. This is common topic. So I want to cover this topic in the binary search tree and AVL tree. Directly I will implement. So how many traversals are there? 3 techniques are there. Anyone remembered? Can you please confirm those names, at least if you heard?
In order, post order, pre-order.
Good. So in order traversals are there. Then pre-order. Okay. So pre-order traversals are there. Third one is post order. Sorry, some people are going to feel it is very difficult for understanding this one, but nothing is there here, sir. Nothing is there here. Please follow my instructions. You people can understand very clear. Sir, consider here I am going to represent root is indicated as a D, and left subtree is indicated as a L. Right subtree is indicated as a R, because for right and root we will get a common character. That's why I mentioned this root as a D. Now, in order means there is one formula, LDR. Pre-order means, so DLR. Post order means, so what is post order? LDR. In order means what? LRD. Like this we get. Sir, what is this technique? Very simple. Observe the key point is nothing but root. You have to focus on key point. Sir, we are going to consider our key point as a, root as a main key point. Now see carefully. If it is in order, where the root is coming, sir? In the middle, right? In order means first priority will be given for root. In the middle root will be there. Pre-order means first we have to take the root. Post order means last we have to take the root. Pre means beginning. You have to begin with the root, then left, then right. Post at last. Visit left first, then right, at last root. In order means what? First left, and then root node, and then right. Like this we have. Sir, once if you see the examples, you will get a clarity. If you want, I will write more meaningful terminology. First we have to visit left, then we have to visit root, then we have to visit right. In this case, first we have to visit root, then we have to go for left, then we have to go for right. In this case, first we have to visit left, then we have to visit right, then we have to visit root. Like this we have, sir. But once if you see the example, then only you people will get clarity. Sir, I am taking first example. Please concentrate. Sir, I am going to take a tree like this. Consider I have a tree like this. Root node is nothing but like this we have. So only 2 children are there. This is nothing but a left child. This is nothing but right child. And the data what we have here is A. And this one is nothing but a B. And this one is nothing but a C. Please concentrate well. I am going to write for example 1. I am going to write in order. Okay. I am going to write in order. First we will write in order. Then later we will go for pre-order. And later we will go for post order. Sir, please listen carefully. In order means what? First we have to visit left. Sir, what is the left node here? B, right? Next we have to visit root node. What is the root node name? A. Then we have to visit right node. What is the right node? C. This is in order representation of that tree. What is the pre-order? First we have to visit root node. What is the root node? A. Next we have to go for left subtree, which is nothing but B. Then we have to go for right child, which is nothing but C. Pre-order. What about a post order? First we have to visit left subtree, which is nothing but B. Then go to right subtree, which is nothing but C. At last go for root. So shortcut, in order means root should be there in the middle. Pre-order means first root. Post order means at last root. Sir, if this small chota application, is it clear for you people? Means I will go with some other example. Please confirm, is the concept is clear up to this whatever I covered?
Yes, sir.
Yeah, clear, sir.
Yes, sir. Yes, sir.
Right.
Sir, sorry to interrupt. Just
Hmm.
wanted to know where is the real-time uses of this topic?
Sir, in the real time, so many ways are there we are going to use. Okay, that I will explain. In the graph and the trees, by combining, I will take one example and I will demonstrate. Okay.
Google Maps.
Hmm.
Google Maps, sir. Google Maps.
Yeah, Google Maps. Everywhere we are going to use. In the route monitoring systems. Okay. Identifying the shortest paths. So finding the easiest way. And in the
File system.
backtracking applications, yeah, file systems, everywhere we are going to use this technique. I think in the command prompt we have that command is also there somewhere. I will show you in the command prompt. Do you know
It's
to
a
see
tree.
the file
Tree
system? Yeah, tree command is there, right?
I have. Yes.
Yes, tree command is there. If you type, have you observed? It is going to print the complete tree structure. So what is the root node here that we have? Sir, C is the root node. 8 p.m. is one subfolder. Like that we have. Okay. So total, all these, whatever content is there, everything it is going to display. Right. Sir, let us go for the next example. Second example I am taking. Listen carefully. Sir, you have to tell answer for this. So we need to find out in order. Okay, we have to find out in order, then pre-order, and we have to find out post order. Have a look once. Sir, somewhat a complicated diagram I am taking. Consider now I am taking this A as a root node. So B as the sub left subtree and C as the right subtree. And D is nothing but we have another node. And E is nothing but like this we have. And okay, let it be. I am closing here itself. Sir, please confirm in the in order. First, we will start from the root node. In order means what? First, we have to visit left. So this is the root. Its left subtree is nothing but B. It is not a single node. Again, it is having a tree, right? So what we have to do? You need to apply that in order principle again for this. Sir, apply in order. First, we have to visit left subtree, which is nothing but a D. Then you have to go for root node B. Then we have to go for right subtree E. Now for A, left part is completed. Sir, now right part we have to visit root node A. Then go to right part. This is nothing but in order. So first I started from the A. You have to visit left subtree. In the left subtree, again it is a tree. So visit left node first, then root node, then right node, because that is the principle, right? LDR. Sir, this one completed. And for main LDR, L and all got completed. Sir, then what is the root node? A. Print that root node. Then we have to take right subtree, which is nothing but C. Like this we have. Can you please confirm? Is it clear, sir?
Yes, sir.
Yes, sir. Yes, sir.
Now, sir, now I want to apply pre-order. Pre-order means what? Root should be having highest priority. Sir, first visit the root node. Yes, completed. Then left child. In the left child, again we have another tree is there. Sir, again we have to apply same principle. Visit the root node. What is the root node here? B. Then visit its left child, which is nothing but a D. So visit its right child, which is nothing but E. Sir, root node completed, left child completed. Right child, is it having any tree? No. Then visit C. Like this we have. Sir, what about post order? Post order means what? Post order traversals. First, we have to visit left subtree. Please listen carefully. Left subtree is nothing but what? B, sir. In the B, again it is having a tree. So visit left subtree first. So D will come first. Then visit right subtree. E will come next. Then visit the node, root node, which is nothing but B. Sir, completed. So left part completed. Still right part is there, right? So what is the right node? C. After completion of this, we have to visit A. This is nothing but what we have. Please confirm slowly if the complexity is increasing. Sir, how you can search? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Sir, next example. Please concentrate well. I am going to draw one more tree now. Sir, somewhere I have displayed this tree, if you remember. Okay. Like one is nothing but root node. Okay. Then 2 is nothing but its left child. 3 is nothing but its right child. 4 is nothing but its left child. 5 is nothing but right child. 6 is nothing but left child. 7 is nothing but right child. Have you observed? This tree already we constructed. Now you have to tell in order. Can you please guess in the in order what is the first element that you are going to get?
4,
4, sir.
4. Then
Then
2,
2,
very good. Then
5,
very
5,
good.
1,
very good.
then
6,
Okay.
3,
3,
7.
That's all.
4.
So in order means what? The first priority will be given for left child. Sir, 1, it is having its left child. So 2, again it is a tree, right? So we have to visit left first. Then root node, then right. So left part completed. Root node, visit this. Then right part. Then right part. Sir, 3. Again it is a child, it is a subtree, right? So 6 will be there. Then 3, then 7. Like that it is going to visit. Sir, next. What is the next step that we have to take? We need to visit for, we need to visit, I mean, we need to take a pre-order. What is a pre-order? First, we have to visit root node.
1,
1. Then
2,
2.
5,
4,
4,
5.
5,
Then right child 3.
3,
3 is the root.
3,
3.
6,
7,
7.
6.
That's all. 6, 7, not 7, 6. Okay.
Sorry, sir.
Yeah. What is post order? I think you got the clarity now. In the post order, first left subtree. In that again it is a tree. So go to left subtree. Can I say 4, 5? Left subtree, right subtree, then
4,
root
5,
node.
2.
Then left subtree got completed. Go to right subtree. In that again it is a tree. So visit left node, right node, and then root. Then
7,
at
6,
last
3.
main root node will come. Got it?
Yeah.
Sir, I think now you are in a position to trace so tree traversals. Is it clear?
yeah,
Yes, sir.
clear.
Yes, sir. Right. Of course, just for your theoretical understanding purpose, I have explained these things, sir. But in the program, it is very easy to implement. Okay, don't worry. Sir, now I want to explain creation of a list. Sorry, creation of a binary tree using list. That is sequential representation I am taking. Sir, now the programming concept will come. Sir, I am taking Python program. So I will save this program in a test folder. No, I will take some other folder with name DSA with Python. So here I am going to take, so the name of the file is nothing but, can I take BT? BT stands for binary tree. So binary tree. I am taking class, okay, or let it be BT1, something like this I will take. So class, I'm taking the name of the class as B tree, binary tree. Sir, every binary tree is represented in the form of double linked list. That's why I'm taking a node class. Already we covered this principle in the linked list. node class is there. In this, how to define the constructor? You know, in the init method, you have to pass self and data field will be there. What about next node? In the next place, we are going to use left. In the previous place, we are going to use right. So for the first data, left field is null, right field is null. So self dot data is equal to, I am giving data. And what about next line? So self dot left will become none or left. So self dot right will become, I am taking right. That's all right. Then, so this is the node structure. What about a binary tree? For binary tree, I'm going to write a constructor. Inside this constructor, I'm going to pass a self and a self dot. Every binary tree will have a root node or not? Yes. Self dot root is equal to, initially that root node is none. Something like in the linked list, we assigned head is equal to null, right? Head is equal to none. In the same way, in the binary tree, I'm going to take root node as a none, sir. If I create object for this tree, what will happen? Sir, assume I am going to create a tree object. Obj is equal to, I created a B tree object I created. Okay. Now what will happen? Sir, immediately one reference will be created with the name obj, which is pointing to root node. Root node. What is a root node, sir? Initially, my root node is nothing but none. My root node is nothing but none. Like this we have. Okay. I think the initialization sector, it is very clear for you. I think so. Right? Any doubts? Clear up to this?
Yeah, clear.
Any doubts?
No, sir.
No, sir.
Now, listen carefully. Slowly, I am going to increase the complexity of the program. What is the next step is, sir, I am going to define one function in the B tree. B tree. You have to write code only for B tree, not node, because the double linked list structure we implemented. Don't touch that. DEF. I am going to create one function called create binary tree. Okay, create a binary tree or create a tree. Like this, I am going to implement one function which is going to take a list. So it will create a tree, sir, by taking this list. Sir, how to create a tree? Just now I told somewhere we can represent the tree in the form of list 1, 2, 3, 4, 5, 6, right? So that is right. 1, 2, 3, 4, 5, 6, 7 also is there, right? So 7, because for 1, 2 and 3 are nothing but childs. For 2, 4 and 5 are children. For 3, 6 and 7. Yes, that's all. Now, by using this object, I am calling, so create a tree function. Just I will pass a list. That's all. This function should create a tree, sir. But, sir, is only list is sufficient? No. That's why what I am going to do is, so I am taking self dot root is equal to self dot. I am calling one more function called create tree util. So create a tree util function I am passing, where it will take a list and first parameter. So here create create a tree underscore util is a separate function which will take a list and index value. Sir, you can do this by here itself, but whatever result that you are getting, you need to assign to the root. But that we can't done here, right? That's why I defined one separate method. When you call this method, what will happen? It will construct a tree that reference I am going to assign to the root. That is the functionality. Now have a look once in the create tree what I am doing. Sir, I am finding the size of the linked list, length of the list. I mean, how many elements are there that I am finding. Your current node will become, so self dot node of L of start, L of start. I am giving like this. Sir, what is the start value? Let us take this one as a start. Now listen carefully, slowly I am explaining the code. Sir, initially my list is nothing but what, sir? we have 1, 2, 3, 4, 5, 6, 7. For easy understanding purpose, 0th location, first location, second, third, fourth, fifth, sixth. What is the size that they have given? Size is nothing but 7. 7 elements are there. So what is current node? My current node is nothing but a self dot node. So it will create a new node. It will create a new node. Automatically, a new node will be created. Please concentrate well. Automatically, a new node will be created like this. Yes, a new node got created. What is the data for that new node? L of start. What is the starting value that we have given? In 0th location, which value is there? 1. With the help of 1, I created one node. Right? Then after this, what we are going to do? Its previous field is pointing to null. Its next field is also pointing to null. Sir, next, anyway, this value I am going to return to the root. Okay, that will be returned at last. Then after this, you have to create left child, right? How to create left child? L is equal to, can I take 2 into start term plus 1? So right child, right index I am taking 2 into start term plus 2, can I take? Yes. Sir, if your L value is less than size, then current dot term left will become, can I take self dot again? So create a tree of util, by passing L comma small l. Sir, if the value of R is it less than size, then I am going to take this one, that is a current dot term right is equal to, so self dot create util by passing the right value. Then I will return that current, sir. Recursion I implemented. Please listen carefully. I am explaining the flow of control. Up to this we have seen. Now I am taking L. L is equal to small l, 2 into start. What is the start value? Just now we have seen 0. Right? Start value is nothing but what, sir? 0. So 2 into 0, 0 plus 1. Left is nothing but 1. Sir, right value we are taking. 2 into 0, 0 plus 2. Now cross check, is 1 is less than size value is 7. Yes. Then current dot left. Is it a current or not? Yes. This is a current. Its left node is equal to, again I am calling create util by passing L comma 1. L comma small l. It will call again. Sir, L is there. Starting value is what? L. L means what? It is 1. Now it is going to check. So L of 1. What is a L of 1? 2. With that it will be created a root with the content 2. Now what is the start node for this? I have given 1, right? L value is equal to 1. That will be passed as a start 1. For that again left will be calculated, right will be calculated. If you want, just observe this tree diagram, sir. Just observe this tree diagram. Sir, first we passed 0th node. For this 0, we calculated left as a 1 and right as nothing but 2. Then what we are doing? Again for this left of 1, we are passing this as a root. So then its left child, for this left node, left child will be created. And for this right child, for this again a node will be created. And for this left child will be there, right child will be there. So again it will be created. So again it will be created. Like this it is going to create a sub nodes, sir. Now what will happen? Sir, when we are taking your starting value as a 0, so 0 into 2, 0 plus 1, that is nothing but 1. This will become your left child. And 0 into 2, 0 plus 2, it will become second location. That data is nothing but 3. It's got completed. Now what will happen? Next time we are checking, is L is less than size. Is 1 is less than 7? Yes. Again we are calling the same function. Now what is the start value? This one, 1. So a node got created. What is the left child to this? 2 into 1, because 1 is the L value. 2 into start value, 2 into start, 2 into 1, 2 plus 1, which is nothing but 3. This will become its left child. And for that right child, 2 into 1, 2 plus 2, 4. In fourth location, 5 is there. That is right child. Sir, please observe here. What is the value of this particular location? It is available at third location. It is available at fourth location. For this left, we have to calculate. So what is the start value? 3. Have you observed? 2 into 3, 6. 6 plus 1, 7. So 7 is less than 7. Condition false. We don't have any left. So if it is not having, then it will return that node, none. Like this, it will be there. For 4 also, 4 into 2, 8. 8 plus 1, 9. Ninth index is not there. So it will return null. But this node is pending for this one, right? So in this case, start value is 2. Sir, 2 into 2, 4. 4 plus 1 is what? 5. So here sixth node will come. Then 2 into 2, 4. 4 plus 2, 6. In sixth location, 7 is there. And this start value is nothing but 5. This location value is 6. 5 into 2, 10 plus 1, 11th. 11th index is not there. That's why these next nodes are going to be assigned with null. Like this, a tree will be created, sir. Can you please confirm? Is the tree structure is clear for you people?
Can you explain how we are getting current one more time? Line number 18.
Line number 18. See, current is the simple variable, sir. Okay. Self dot node. I am calling a node function. So node means what?
Sir,
It is
can
the
we
class.
Sir, can we take stack using stack? Can you please trace it, sir?
Why? Okay. You are asking about tracing. Yeah.
Yes, sir.
Yeah, please listen.
But
Sir,
it is
here-
not in here, non-tail missing also available. Non-tail
Uh-huh.
trace, non-tail recursion also. Non-tail recursion also is in confusion.
Why confusion? Here simple concepts only there, right? We are doing 2 times recursively. What method? Create util method we are calling recursively. Okay, please listen. Sir, now here some student asked one doubt, how this current node is going to work. Current is equal to self dot node. If you want better to go for from the beginning. Have a look once. Sir, first, this is the list what I have. I called create a tree function. It is coming here. And we are going to call create util. What is the starting index that I am giving? 0. So let us identify these indexes. 0th location, first location, second, third, fourth, fifth. Please listen carefully how it is going to work, sir. Sir, now I am calling, okay, I am calling this function self dot node. Node is the class, right? So we are creating object for this. We are passing L of start. That will be taken as a data and it will create a node. It will create a node. Sir, how that node will be created? Can I say this is nothing but that node or not? Yes. How many fields will be there? 2 fields. This is nothing but a left child and this is nothing but right child. What about the data? That data is nothing but L of start. Sir, what is the start value that you have given? 0. In 0th location, which element is there? 1. With the element 1, we got a node. We got a node. What is the name of this node? Can I say, is it a current node or not? Yes. That reference we captured. Got it, sir?
Yeah, understood, sir. So my dot was that 0. Yeah, it cleared.
Now what will happen? We have to calculate. Next immediate instruction is what? Left value. What is a left value? 2 into start. Start value is 0, right? Just now we have seen. 2 into 0. 0 plus 1. Your left will become 1. Your right index value will become 2 into start. That is nothing but 2 into, better to write right index here. Your right index will become what? 2 into 0. That is nothing but 0 plus 2. That is nothing but 2. That means this node left child is available at first index. This node right child is available at second index. But again, it is having left and right, right? That's why we are checking. Is left is less than size? Yes, it is less than size. Then left current dot left. This is the current. Its left node is pointing to again create a tree. So it will call the same function. Length is the same. Now this will become your current node. That means what? We will get another node we are going to get. Sir, now what is the current node? This one will become current node. Okay. Now self dot node of start. What is the start value here? 1, right? In first location, which element is there? 2. That will become its left sub. This one I am executing. For this again left subtree will come. What is the formula? 2 into start. Start value is what? Sir, here we have passed right 1. So 2 into 1, 2 plus 1, which is nothing but 3. And its right child will become, so 2 into 1, 2 plus 2, that is nothing but 4. Okay. Sir, now what will happen? Is L is less than size? Yes. Then what will happen? Left is going to be created. This is the current node. Its left child will become. Sir, again create a tree. I am passing L value. That is nothing but 3. It will be called. Now current node will become. Again we are going to create one more node. Sir, this is nothing but left. This is nothing but right. What is the data? So yes, L of 3, right? What is the L of 3? 4. Like this we are going to get. Sir, again it will calculate left. What is the left? Sir, 3 is nothing but the start value. 2 into 3, which is nothing but a 6. 6 plus 1, 7. Automatically your right will become 8. Then is L is less than size? No, condition not satisfied. So by default already none is there. So we are not reassigning. Then sir, is R is less than size? Not repeated. So because the condition is not satisfied, it will go back. Sir, for this current node, we created only left. Again, right, we have to check right. Is 4 is less than size? Yes. Then it will create a right subtree. Sir, what values it is going to consider? It will take L of 4. L of 4 contains 5. Then for this again left subtree will become 4 into 2. 8, 8 plus 1, 9. If it is 9, this one will become 10. Sir, is there any 9th location and 10th location? No. So this right subtree also completed. Main tree left subtree completed. Like this it will be repeated, sir. I think at least now you got the clarity, right? Please confirm everyone. Is the concept is clear?
Yes, sir.
Yeah, sir. Clear.
Right. Now what we have to do? Sir, almost every job got completed, sir. Now you have to print the data, sir. Now you have to print the data. Sir, DEF, I am taking in order. I want to print the data in order. I am defining the function, but it internally calls self dot in order util function I am going to define. Sir, where it is going to take self dot argument is mandatory. That's why I am taking like this. Now we have to implement that function also. What is that function? So in order, okay, in order underscore util function I am taking, where it is taking self comma node. We are passing a node. How to implement? So means what? Just simple example I am taking. I have a tree like this. So consider this is nothing but 1 and this is nothing but 2. This is nothing but 3. I am passing which element, sir? Root node I am passing. So if you are passing root node, what we are going to do? We will check, is that root node is not equal to none. If it is not equal to none, can you please call self dot in order, self dot in order util of node dot left. Sir, this is the node what we passed. I am marking in red color. This is the node which you passed. Sir, is it not equal to none? Yes. Then go to left child. Sir, node dot left. Now this will become node for the next time call. Is node is not equal to none? Yes. Then go to node dot left. Then it will become none, right? So if node is not equal to none, it will keep on calling. That means we are moving towards left. Once if the node is none, then what we are going to do? Sir, we will print node dot data. Node dot data. Sir, what will happen? When you came to here, node dot data will print. Sir, completed. Then what we have to do? You need to go for right subtree, right? So now you can see. So I am going to call same in order function by passing node dot right. Sir, can I say in the in order, first we will visit left subtree, then we will visit root node, then we will visit right subtree. That's all, sir. Recursively, it is going to keep on calling. That's all. Beyond that, nothing is there. Program got completed. Sir, now I created a binary tree. Now what we have to do, by using this object, we are printing in order. Let me run this small Python code, whatever we have written. Maybe mistakes will be there. So let us clarify what mistakes are there, then we will implement. Sir, where it is available in the tree? No. CD space DSA, something like this we have. Yes.
B3.
Py space. What is the file name that we have given? So
B3,
tree
sir.
or yeah, B3 1, right? Now you can see, sir, we are getting like this better. Here after this I am taking end is equal to space. Sir, end is equal to space. Now let us cross check. Sir, this is the in order for that tree. Sir, if you see, this is the list whatever we have taken in the previous example. Have you observed? Is the in order is correct? Have a look once. Sir, 4251. 4251. Sir, 637. Perfectly coming, sir. Can you please cross check pre-order and post-order also? Are no problem. Same thing will be there, right? Is there any change? No change at all. Pre-order and post-order. In the case of pre-order, just we have to take a pre-order here. So here I will call pre-order. And here I'm going to call pre-order util. And here I will take a pre-order util. Okay. And here I will call pre-order util. But in the pre-order, first we have to print the root node, right? Then left, then right. Sir, what about post order? If you take a post order, in the post order, the first priority will be given for left child, and after that right child, and at last we have to visit root node. So we need to bring this print at the end. Sir, it is calling recursively. Now, can you please call in post order or pre order, and after that post order? Have a look once. No, or pre-order, somewhere spelling mistake.
Pre-order double order.
Where, sir?
If you go
Line number. Here we have
36.
taken double R. Yes, but I think in the util function, after printing this, I will call empty print so that the control will go to the next line. Right. Now have a look once. Oh, still somewhere in the in order also try to print. Now have a look once. Sir, in the in order, first we called in order. We checked pre-order. Is it correct? 1, 2. Okay. Sir, let me cross check. Sir, 1, 2, 1, 2, 4, 5, 3, 6, 7. Yes. 4, 5, 2, 6, 4, 5, 2, 6, 7, 3, 1. Have you observed? So how beautifully implemented, how beautifully we implemented. I think you people understood very clearly. Do you have any doubts, friends, up to this? Please confirm.
Yes, sir.
No, sir.
Now, I have a question for you. What is the question is? Sir, I am taking one more tree. Please have a look once. Try by yourself and tell me the answer. Sir, I am taking root node as a 1. Its left child is nothing but a 2. Its right child is 3. For this left child is 4. Right child is 5. For this left child is 6. Right child is 7. For this left child is 8 and right child is 9. For this left child is 10. Right child is 11. For this 12 and then 13. And for this 14 and 15. Like this we have. Sir, try to calculate in order for this. So later you can try, but I will explain with the help of program and you have to tell is it correct or not. Sir, what is a list of values? Can I take this list like this only? So 7, 8, 9, sequential representation. So 10, 11, 12, 13, up to 14, 15, right?
Yes, sir.
Yes. Now you can see. Let me cross check. I am executing the program. Sir, at least in order we will try. This is the in order what I got from the program. But let me check, is it correct or not? We have to cross check. This is the in order what I got. Now let me try. Sir, try to start from the root node. Sir, in order means what? First left subtree. So here left subtree is nothing but this one. Again it is having a tree. Again left subtree. So again it is having a tree. So first we have to visit 8. Then we have to take 4. Then we have to take 9. Left subtree completed. Sir, after this what we have to do? Visit the root node. That is nothing but 2. Sir, then right subtree. In the right subtree, again it is a tree. So go to left, then visit root node, then right. So it's a right subtree got completed. Sir, this total left got completed. Sir, then root node, which is nothing but 1. Then go to right subtree, again it is a tree. Sir, again go to 6, again it is a tree. Take 12. So then visit 6. Then visit 13. So left subtree completed. Then root node 3. Then right subtree. Again it is a tree. So go for 14. Then visit 7 and then visit 15. Is it correct? 8492, 8492. Sir, 10, 5, 11, 1, 10, 5, 11, 1. Then 12, 6, 13, 3, 12, 6, 13, 3, 14, 7, 15, 14, 7, 15. Sir, is the in order is coming or not? Please confirm. Is it clear?
Yes, sir.
Yes,
Yes,
clear.
sir.
Yeah, I'm not writing the total program to explain this case to just that list change alone I'm going to take. This is nothing but how to represent the linked list. I mean, how to represent the tree by using list, sir. Any doubts?
No, sir.
No, sir.
No, sir.
Now, sir, observe carefully. Now I'm going to take sir, if you want, you can implement this without list also. So means what can I say? This binary tree implementation, by using yeah, a binary tree implementation without using list. Can I do this? Yes, of course. It is not recommended approach, but just for our understanding purpose I am telling. So we are not going to call create tree function. Okay, we are not going to call create a tree function. Then sorry, we are not going to take this list. Okay, now let us see what will happen. This create tree function won't be there, and this function also won't be there. Remaining things will be there. Now please listen carefully how I am going to create the node. I will take one simple example for you to understand. For example, I am taking the root node as a 10 and its left subtree as a 5 and its right subtree as a something like a 12. Like this I will take. Now have a look once. Sir, obj is equal to, I created b-tree1 object. Then obj dot root node is equal to, what is a root node? Sir, I am taking obj dot, I am creating a node. N caps, right? Sir, have a look once. Is N caps? Yes. I am creating object for this by taking the node as a 10. 10 is the root node, right? Like that I created. Then for that root node, what is a left child, sir? Sir, obj dot node of 5 or not? Yes. Sir, what is a right child? 12. Like this we can make the links. It is a very complex process. Now have a look once. If I run the code, please listen carefully. Sir, in order, is it correct? 5, 10, 12. In order. Pre-order, sir, 10, 5, 12. Post order, 5, 12, 10. Perfectly working. Now assume I am attaching. Okay, I am attaching. So for 12, I am attaching 11 and 13. Now what will happen? Find out the in order. So first 5, then root node, that is a 10. So then right child, again it is a subtree. So left child, root node, right child. This is the in order, right? Let me cross check. For 12, 12 means what? Root node right child is there, right? For this right child, again left node will become one value, right node is having one value. What is the left node value, sir? It is 11, right node value 13. Now execute this code. Sir, is in order 5, 10, 11, 12, 13 coming or not? Yes. Like this, we can able to implement without having any list object. I think you understood this terminology. Sir, in the tree data structure, we can't able to insert nodes explicitly. The reason for that is nothing but, so do you know, this tree, binary tree is not going to follow any technique for inserting the data. Any data you can give, happily it will store. We don't have any restriction. The only restriction is every node should maintain only 2 children. That is the root. That is nothing but the technique what we have. So except that there is no other alternatives. Sir, I think you understood this concept clearly, right? Do you have any doubts, friends? Please confirm everyone.
No, sir.
No, sir.
But anyway, to explain these concepts, I am not going for this one. Just I am going to take this one alone. Okay, like whatever example I covered previously, I will take this one only. So I will take that B tree class is there, right? Here I will paste. So what is the next case list we have taken? This one. I am updating this list. Let us try this execution one more time. So I am taking B tree, BT. So perfectly coming. Sir, this is nothing but what I have my main tree, sir. Any doubt in this binary tree implementation? Please confirm one more time.
Sir.
Now, sir, next we will implement some algorithms in the tomorrow's session. Sir, in this we are going to see level order traversing. Then we will see counting of nodes. How many nodes are there? How to count? And sum of nodes present in the list. I mean, it's present in the tree. Then how to find out the height of the tree. Okay, height of the tree. How you can find out. Next and after that, a search operation. Next and after that, finding maximum element present in the binary tree. So finding minimum element present in the binary tree. Next, number of leaf nodes. How many leaf nodes are there? Then we have to print all paths from the root to child. And how you can check whether equality of 2 trees. So then how to perform copy operation, copy of the tree. Like this we will see these basic operations, sir. Okay, so tomorrow I will explain these operations on binary tree. Then I will explain binary search tree theory concept. So theory concept, then binary search tree implementation we will see. Almost all these concepts will be same, but in addition to that, we are going to see few more insertion operation, delete operation, because binary search tree is going to follow some technique at the time of insertion and deletion that I will explain. Okay, sir, tomorrow also same timings will be there, 8:15 to 10 o'clock. I am going to take maybe 9:45, like that I will wind up. Tomorrow at any cost we will try to finish this these implementations and binary search tree implementation. and I will give input for AVL tree also. Maybe AVL tree insert operation we can finish. Okay. AVL tree delete operation will be there. That I will explain on the Monday. Monday also same timings will be there. Okay. Right, sir. That's all about to today's session. Tomorrow we will meet for the continuation. Same link you have to use. Okay.
Sir, can I get the running notes for the batch 2 actually?
Batch 2 Mohit.
Yes, sir, because
yeah, you have messaged me, right?
right, sir.
Yeah,
Because
just
I
to
can't.
give your mail. Yeah. Just to
Okay.
give your mail ID.
Okay, sir. Oh, I will WhatsApp to you, sir.
Yeah,
Is it
you.
okay?
So one second. Yeah, can you please cross check? I have given invitation. Just
Yes, sir.
join
Yes,
into
sir.
that group. Okay.
Yes, sir. I have joined it.
Yeah, don't worry. I will share this material running notes now itself. Okay, after completion of the session. Right, sir.
Okay.
Thank you. See
Thank
you
you so
tomorrow.
much, sir. Thank
Yeah,
you so
thank you.
much. Bye.
Thank you, sir.
Thank you.
Right, sir. Thank you.
Sir,
See you
thank
tomorrow.
you, sir.
Thank you.
2 more videos on YouTube, sir.
Sure.